Okay, hello, and thanks everyone for coming. This looks like a mini keynote town hall with a number of people here. So I believe it's the topic of the day is AI and machine learning in general, combined with serverless, right, which is of interest. Definitely. How many people here have tried to use KNative or have heard about KNative? Quite a bit. So that's great. I mean, before I begin the talk, right, one of the things I do want to make sure to convey is that, essentially, while we are trying to do this and build this ML platform leveraging KNative is still in very early stages. It's an evolving project, right? There are a lot of bright points in terms of the concepts and where it intends to be. But definitely, there is a lot of work which needs to happen on other components of KNative. Myself is Animesh Singh. This is my colleague, Tommy Lee. Together, we work for IBM in a group called CODE, Center for Open Source Data and AI Technologies. And we work on open source projects throughout the AI lifecycle around the three pillars of code, content, and community. We contribute heavily to Spark, TensorFlow, Keras, a lot of other projects from IBM's open source around the AI lifecycle. We create a lot of content around them. We work very closely with the Watson product teams, the cloud product teams in terms of making sure that these open source technologies are getting incorporated inside our products. And then we work heavily with the community, right? Whether it's contribution to open source, it's creating tutorials, how-tos, conference talks, meetups, etc. What are we going to talk about today? Essentially, some progress in machine learning and deep learning in general, why we think AI and cloud are complementary. Then one of the questions, right, why do we need something like KNative to build an AI platform? Is it really needed? And then how do we build a transparent and trusted AI platform leveraging KNative? Followed by a quick demo. For me, the first time when I heard about AI in general was back in 1997 when I was back in India, when IBM's Deep Blue beat Garry Kasparov in chess. That's when this whole notion of machine learning, artificial intelligence, that's something crossed my eyes. And then 2011 was another aha moment when Watson actually beat Jeopardy champions, right? And very recently, which probably most of us have heard, is essentially DeepMind going against and winning the Go championship. And as of the beginning of this year, there was a debut of IBM Project Debater, which actually won very compelling arguments against a lot of professional debaters. So that starts taking us into the AI reasoning space. So if you look at the progress in deep learning in general, it was not until 2012 with the advent of AlexNet where actually GPUs started getting used heavily. And then Facebook's face recognition, I would say, would be the first widespread adoption of deep learning. What exactly is deep learning? Essentially, we are training artificial neural networks. If we look at the capacity which it has achieved, around 25 million neurons, 100 million connections, compare it with human brain. 200 billion neurons, 32 trillion connections. So that means what deep learning has achieved today is only 0.0003% of what a human brain can do. But in spite of achieving that less of a capacity, it's able to do so much. That's humongous. What does a typical neural network design workflow look like? Right? A data scientist comes, designs the initial neural network, then you assign hyperparameters, point it to your domain data, and then train the model. As you are training the model or after you have trained the model, is the performance meeting your needs? No. Then you go and retweak your hyperparameters, start another experiment, right? And you go through this in several loops. If it does meet your need, then you have the trained model, which you actually go ahead and deploy. But your job doesn't stop here. Typically, most of the applications, once you deploy, right, they perform consistently. In case of models, when they're actually deployed in real world, when they're actually predicting and doing inferencing against real world data, you start seeing, drift, you start seeing accuracy loss, you start seeing predictions, which were way off, right? So that means you have to again start another experiment, go through this process. So one thing is very clear. AI in general and deep learning in particular are very, very iterative and very, very repetitive. So they need cloud, right? It requires the strength of HPC and GPUs. You want to be able to scale your AI workloads on demand. And you also want to utilize various technologies to achieve high-performance computing. So a lot of innovation which is happening around different algorithms, around model parallelism, data parallelism, the innovations which are happening at the hardware layer with MPI and Nickel, right, coming out of NVIDIA, essentially is making sure that you're optimizing GPU to GPU communication, not only a single machine, but across multiple machines. The best way to consume them and leverage them is using cloud. So it's very clear that to scale, we need to go cloud native for AI. That means we need the concept of microservices, containers, DevOps automation. So that means we use Kubernetes. It's very well established that if you're thinking cloud native, we are using Kubernetes. But is Kubernetes enough for a cloud native platform, right? If we look at the layers, there are multiple layers. So as Kelsey Hightower says, right, Kubernetes is not the end game. It's a platform to build another set of platforms. And that's where some other aspects come in. So what else do we need? Let's understand it from the context of an AI lifecycle, right? Typically, in AI lifecycle, you prepare and analyze the data, then you create your initial model, you assign hyperparameters and train, then you validate your model against robustness checks, bias checks, etc., deploy your model, then continuously monitor it, capture the payload, and then make sure that it's not drifting, the accuracy is right. So what we need essentially is a transparent and trusted AI platform so that you are able to see what's going on throughout this AI lifecycle. Is the training data changed? Is the data set biased? Is model training showing increasing loss? Are model weights biased? Or the classifiers which you use, they are biased, right? Are the model predictions accurate? And ideally, you would want this to be automated, right? So what you need is transparent, trusted, automated, and event-driven AI pipeline. So instead of you going and looking at everything which is going on inside the platform, as you are running through this AI pipeline, the platform should be able to tell you that what's going on, whether the model accuracy is low or the data set is biased. You should be able to be notified. And based on those notifications, the platform should be smart enough to take certain actions to handle those, right? So as far as possible, you don't want to bring a human in this loop. And when we work with enterprises, it's very, very critical that we need the notion of auditability, right? So that means having the right concepts around data versioning, model versioning, tracking every input and output is very, very key to a platform or a pipeline like this. And in the end, right, we are targeting two sets of users. One, the data scientist who will actually submit their machine learning workflow onto this platform or pipeline. And the second set is the DevOps operators who are actually, ensuring that the backend can be supported, how much is the execution time, looking at the logs if things go wrong. And in something which is, so long running as this, things will go wrong, right? So having a very robust view for data DevOps operators is very, very necessary. Now, if we translate it to a logical architecture, it will look something like this, where we have one actor, which is AI developer and data scientist. Then we have AI operators. And for AI developers and data scientists, for the most part, their world is Python, right? They want to enter it through a Python world. You want to give them ability to actually craft these pipelines using a sequence of Python functions. And on the backend side, right, you have your complex pipelines around vertical domains like on data, on training side, on model serving, and then the operations beyond the model serving. So we definitely need more than Kubernetes, right? We need to build data scientist code. We need to be able to orchestrate that machine learning code. And beyond that, we need to be able to certain events and triggers, and we want to automate that whole machine learning workflow. So that means we need the concepts of build, serving, eventing, and pipeline. So we need KNative, right? So what exactly is KNative? So it provides a set of building blocks to enable modern, source-centric, container-based serverless workloads on top of Kubernetes, right? So there are a new set of CRDs which have been created to provide high-level API abstractions around the 4 key areas right now, which are build, eventing, serving, and pipeline. If we look at build, what does it mean? Essentially, source to container orchestration. Now, if you look at it in the context of AI lifecycle, right, take data scientist code and then run it, right, build it so that it can run on top of Kubernetes. KNative build components are essentially build, builder, and build template. A build is a collection of steps. Each of these steps can be backed by a builder, and builders in general are container images, right? And a build template is a parameterized and reusable template which you can use along with your builds. Eventing is all around the delivery and management of events. So the idea is there are some certain sources which will fire events. Those events go to a channel, and there are certain clients which are subscribing to those channels, right, which will take certain actions based on those events, right? So that's the concept around eventing. And something which has come up recently in the KNative world, the KNative pipeline, which is essentially how do you configure and run CI/CD pipelines leveraging Kubernetes, right? So the concept of tasks, applications, runs. So essentially, a collection of tasks forms your pipeline, and then you instantiate a pipeline that's a run, and multiple runs can actually, point your experiment. And last but not least, the most mature component of KNative is essentially KNative serving, right? This is the first one where a lot of work actually went in, right? And it is built around the pillars of configuration, revision, route, and service. Let's understand them a bit. Revision is essentially built on top of deployments, Kubernetes deployment primitives, which builds on top of replica sets. So that means, based on your request, you can scale up. But also, which came in something new, is essentially, if the request goes down, you can scale back to 0. Now, revisions are immutable. They are essentially snapshots of your code and configuration. So that means, to actually create a new revision, you will have to change the configuration. Once you change the configuration, a new revision is created. Then there is CRD around routes. So routes are essentially long-lived, stable HTTP endpoints through which end users access your Kubernetes KNative applications or services, right? So routes can actually point to a particular revision, or you can actually split traffic between multiple revisions. So we need configuration, route, and revision within the KNative serving. And to create all these objects, there is a higher level abstraction which has been created in KNative, which is KNative service. So a service actually creates a configuration, creates a route, and then as you're creating multiple configuration, you're getting different revisions. So essentially, KNative uses Kubernetes CRDs to define a new set of APIs around build, eventing, serving, and pipeline. Great. But do we really need something like KNative to build an ML platform, right? So for those of us who are actually, living and breathing the machine learning world, does it still make sense that you need something like KNative? Let's go through our own use case. We have been, as part of our group in Code, right, we have been trying multiple use cases with open source technologies. What will be the right strategic platform, right set of open source technologies to build our ML platform? We do have a lot of hosted platforms, right, under our product umbrella, but looking at the next gen, how should it be built, right? So if we look at the first part, which is essentially, how do we create your initial models, right? There are many tools available. Jupyter Notebooks, RStudio, Anaconda, SPSS Modeler, very well established. The second part, right, where essentially then you are performing complex mathematical functions, so many libraries, which have been popular like scikit-learn, XGBoost, and now with the advent of deep learning, TensorFlow, PyTorch, MXNet, etc., right, which are being used. If you go to, for example, in China, Paddle gets used heavily. If you go in Japan, Chainer is something which is used heavily, right? So also here, a lot of people like TensorFlow, but it had static graphs. So PyTorch's dynamic graphs became more popular, right? So how do we handle first all these different multiple open source frameworks in a consistent manner? For that, we launched something called Fabric for Deep Learning, or FDL. It essentially is a distributed deep learning training platform on top of Kubernetes. It is the winner of InfoWorld's Best of Machine Learning and Deep Learning Software for this year, right? And it provides a constant way to actually train your models, visualize your model metrics, etc., as the training is going on. And we have been working with community partners to ensure that we complement the capabilities which come in FDL. So for example, with Selden, to make sure that we have an open source counterpart on the model serving side, with H2O.ai to bring some of the machine learning algorithms they have developed, which are hugely popular, into FDL, with Uber actually to leverage their Horovod distributed training mechanism, which works on top of MPI and Nickel protocols and gives performance many times better than the native algorithms out there. And then we were working very closely with Facebook for PyTorch 1.0 launch, and we announced the support for PyTorch 1.0 on the same day as Facebook, announced PyTorch 1.0 release. Essentially, FDL is built using microservices architecture on top of Kubernetes, and we are leveraging scalability, resiliency, fault tolerance, which comes from Kubernetes into Fiddle, we have been testing on community Kubernetes distribution, on IBM Cloud Private, our public cloud version, on DIND, right? So you can actually run it on various distributions of Kubernetes. And the idea is definitely right. We want to access compute when the request for a training job comes in. We actually spread that training across multiple containers. So that means A, your infrastructure is only used when needed, and once the training jobs complete, then the infrastructure is released back. This is the high-level architecture for Fiddle. We essentially have control plane microservices, starting with REST APIs, going all the way to Lifecycle Manager, which essentially is the brain. And then the learner pods, where essentially, on request, when the training job comes in, they are launched, and they have certain sidecar or helper processes which actually collect a lot of the logs and evaluation metrics, stream it back, store it in Elasticsearch, and you get a very good visualization of how your training is going on. You can actually interact with it using CLIs, browser, definitely Jupyter Notebook, and we are actually working on our integration as well. But another thing which we found which was missing in Kubernetes was essentially the concept of batch scheduling. The Kubernetes scheduler on its own leaves a lot to be desired for batch workloads. So when you are running distributed deep learning training jobs or machine learning training jobs, these are long-running jobs. And you have something which comes as a high priority, right? You have to halt certain jobs, make sure the high priority request gets in. You need the concepts of gang scheduling, priority, being able to pause certain jobs. For that, IBM contributed a project in open source called KubeBatch. It is in Kubernetes Incubator. Now it's being worked on and heavily contributed by the community, essentially becoming the answer for batch scheduling on top of Kubernetes. So a lot of the concepts I talk about, preemption, halting a job, being able to make sure that we give high priority requests, a leeway and pause the low priority jobs, that is being built into KubeBatch. And it's actually being used heavily within IBM and in a lot of products as well. Another data point is that, right, IBM Watson Workloads, we have it running on Kubernetes. Right now, there are 12 Watson services which are leveraging Kubernetes, around 800 plus Kubernetes services. And each of these services out of 800, on an average, runs around 3,000 plus pods on 500 plus nodes. So as you can imagine, we are leveraging Kubernetes heavily within IBM to run a lot of our AI and ML workloads. So great, we have training accomplished using Fiddle, right? Our model is ready. Can we trust it? How do we validate and trust our model, right? Now, what do we mean by trusting a model? Is it fair? Is it easy to understand? Can anybody tamper with it? So let's start with vulnerability detection of models. Is the model vulnerable to adversarial attacks? Can somebody contaminate the data set and have model bring or start giving very, very vastly different predictions? For that, we launched a tool in open source again called Adversarial Robustness Toolbox, or ART in short. And it's essentially a Python library which has a lot of attack and defense methods implemented out of research papers. So you can actually point to your models, check for vulnerability. And if vulnerability is found, then you can actually implement one of the defense mechanisms. So that helps you do the robustness check, right? Another topic which is very hard for model validation and which is very hot as well, right, which is being talked about is the bias part, right? So is your data set actually, to begin with, was biased? Are the model weights and the classifiers which you are using, they are biased? Once your models are deployed, it starts giving predictions. Are they biased, right? So for that, we launched a tool called AI Fairness 360 in open source, AIF 360. And again, a Python library which implements more than 30 plus metrics on which you can detect for bias. And then it has a lot of bias mitigation algorithms, right? It works across the entire AI lifecycle, not only to detect bias, but also mitigate bias wherever you find it. And as I said, that you can actually use it to detect bias at different levels of the whole AI lifecycle. It gives you metrics, algorithms, and explainers explaining why it found certain thing biased, and then algorithms to mitigate that. So our model is trained, tested, and validated. Should we just deploy it as microservices on Kubernetes? Do we need anything else, right? So a couple of questions arise, right? How can I add and enforce policies on my models, right? So a certain set of users, are able to access a certain version of the model. As I talked about, this model training process is very iterative. very repetitive, right? So at many points, you will have different versions of the models coming in. How do you actually do A/B testing, canary testing, do a dark launch? A lot of those questions arise. For that, we use internally in IBM Istio, right? And I think a lot of us are aware Istio is an open service mesh platform to connect, observe, secure, and control microservices. And essentially, we want to control the traffic. We want to discover, microservices, provide load balancing around them. And it also gives a lot of metrics, logging, and tracing capabilities. The other key aspect of Istio is essentially that, there is a secure TLS communication between microservices, so you get a lot of the security associated with it. And last but not the least, definitely, the policy enforcement piece. And how does Istio work in general? Suppose a microservice A calls B. You deploy Envoy sidecar along with the microservice, right? And the job of the sidecar is to actually intercept any incoming traffic or outgoing traffic, right? So we install a pilot. Then you need a lot of the telemetry. You need logs, you need tracing, etc. So you deploy telemetry, right? And finally, you deploy Citadel, right, to assign identities and enable that secure communication between microservices. And last but not the least, policy to enforce policies based on which users can access, from where they can access. And then once you have Istio, then you can have this inference platform, right, which can then allow you to launch multiple versions of your model and then be able to control traffic between them, be able to split traffic between them. Based on a particular user, you can actually redirect traffic to certain users, or you can enforce certain policies, right? And the great part is, Istio is part of KNative, right? So that eliminates the need for someone, to actually looking at two different things, bringing them together. If you're looking at KNative stack, the idea is that, Istio comes along with it. So that's great. So model is deployed, right? What else do we need now? We need to ensure triggers and actions can be defined, right? Based on any vulnerability detection, dataset changes, bias detection, etc., right? Enter Apache OpenWhisk. So we use OpenWhisk internally, essentially. We have our IBM Cloud Functions platform based on it. It's in open source since the last 2 to 3 years. It's part of Apache. And we have partners like Red Hat and Adobe who contribute to it. And the whole idea behind OpenWhisk is essentially a service platform to execute actions in response to certain triggers, right? So you have sources which are generating events. Based on that, triggers actually encapsulate the response. There are certain rules which define, based on a certain trigger, what action should be taken. And then, that particular action is taken, and then we have the results. You can actually write your OpenWhisk functions in multiple languages: Python, Swift, Go, Node. More so in the ML world, Python becomes very important, right? We are actually also working with Pyren to actually include some of those capabilities in OpenWhisk. And you can actually run it on Kubernetes, Mesos, Docker Compose. So that means, any flavor of Docker you need. And we have a lot of event providers integrated within OpenWhisk. So that means, periodic cron jobs, which can actually emit triggers. CloudEnt, which is on CouchDB under the covers. So any data being stored in CloudEnt or CouchDB will fire an event. Message Hub, which is, Kafka under the covers. Mobile Push, GitHub. Any activity on GitHub, we can fire an event and then have actions which can process those. And the great news is that OpenWhisk is actually being developed to work with KNative. I mean, just today and yesterday, you would have heard announcements where IBM, SAP, Red Hat, Google, they are joining hands together in terms of evolving KNative, more so on the serverless side. And there is a lot of work happening, both on the IBM side as well as with Red Hat, where essentially, we are ensuring OpenWhisk becomes a first-class citizen of KNative. So we trained our model, we deployed our model, we are able to validate it using robustness check, fairness check, right? What do we use for pipeline orchestration? Well, so internally within IBM, right now we are using IBM DevOps toolchain, which is built on top of Jenkins. On open source, we are investigating a lot of technologies: Pachyderm, Argo, Airflow. All these are interesting technologies which we are investigating for AI pipeline orchestration, right? KNative actually comes with its own pipeline, though the caveat here is, it's still in very early stages, changing and evolving rapidly. Finally, once your AIOps platform is ready, right, how do data scientists interact, for example, using Jupyter Notebooks? So for that, we launched a project initially in the Jupyter incubator system called Jupyter Enterprise Gateway. Now it's a top-level project in Jupyter. And the idea here is that when you're working with Jupyter on your local laptop, and if the capacity is not enough, then you can actually launch Jupyter kernels remotely on a Hadoop cluster, on a Kubernetes cluster, and leverage that capability, right? What we have also done is given a single button integration using Jupyter Enterprise Gateway to actually launch your training jobs on top of Kubernetes and then be able to look at the streaming logs and data. Now, if we combine all these things together, right, all these open source projects we talked about, starting from the IDEs for data scientists, then looking at deep learning libraries, building something like Fiddle on top to actually abstract away a lot of the complexities and differences between deep learning libraries, using Adversarial Robustness Toolbox and AI Fairness 360 for model validation and detection, using Seldon for model serving in the open source side, then being able to, again, once your models are deployed, being able to capture that payload and look for bias and other metrics there. We can actually build our AIOps platform. With that, we'll go into a quick demo, right? And what we are going to use in this particular demo is essentially a PyTorch gender classification model, right? Which is a very simple model, right? Using CNN with 3 convolutional layers and 2 fully connected layers built on the UTK phase data set. And it has a very simple job, essentially to be able to predict, whether the image uploaded is a male or a female, right? And if we look at the demo flow right now, what we are using is essentially we are using Fabric for deep learning under the covers for training on top of Kubernetes. The data is stored in object storage, right? And then, once the model is trained, then you have the ML code. Then, we use KNative build, source to orchestration, to actually create containers for robustness check, which is under the covers, using our toolbox. For fairness check, using AI Fairness 360. And then, deploy the model. Finally, we will also show that, once your model is deployed, and you change something, you launch a new version of the model, how do you actually do canary testing on it? So with that, I'll pass on to Tommy.
Hi, I'm Tommy, and now I'm going ahead to show you our demos for ML pipeline using KNative. So for the demo flow, we first built the AI Fairness 360 and Adversarial Robustness Toolbox using KNative build components, then servers using KNative servers. Then from there, we will roll out new release of the model using canary release. Then we will apply some KNative route rules to split the traffics and perform A/B testing. And lastly, we will orchestrate all these components using Argo to perform the actual AI pipeline workflow. So to build and serve the pipeline components, we use the KNative service. It contains 2 major parts. The build part, which we use the canonical templates to build these containers using source code from GitHub and push to Docker hubs. And from there, we roll out our revision using the image we just pushed. And the process here is KNative serving will first generate a container that builds the image. And then once the image is pushed, it will actually create deployments to serve that image. And for the purpose of these demos, we already built all the containers, as you can see over here. And all the containers also serve using KNative servers. In this case, we're using Kiali to show how the Istio traffic is routing in our demos. So now let's go ahead and start with our demo by submitting a training job on our Fabric for deep learning platforms. So on our platforms, it's very simple to submit model trainings. All you need to do is to submit a zip file that contains all your model training files, and then a manifest file that specifies where your data is located and how many resources you want to consume for these training jobs. And once we submit a training jobs on the Kubernetes cluster, it will allocate the necessary resource to run these training jobs. And you can see the details of the training job and the loss of it. Since this job will takes a while to train, so now let's go ahead and look at one of the completed jobs. And as you can see, this model is trained with PyTorch. And you go over the logs, you can trace how the training is done. And you can see here is our model graph. And we only train 5 epochs because we just want to show simple models for our demos. And now we have our model trained. We want to go to our pipeline UI and show you how each pipeline component is done. So over here, we can see our training status is complete. And we want to submit a robustness check. Essentially, we will apply a attack methods to add some perturbation to the gradients and see is the model able to handle those attacks. To do this, we submit a chart which have our credentials with our data and trained model located. We click submit. And from KNative serving, it will see this traffic want to do some robustness check. So it will provision a new container that scale from 0 to 1. And if you look back to our KRE graphs, you can see this traffic coming to the robustness check native service. And then later on, you can see since we don't have any containers, the robustness Python KNative service will ask the autoscaler to scale it from 0 to 1. And once the robustness check is done, we will return a list of metrics. As you can see, the base accuracy for this model is 0.87%, which is not very ideal. And with like 0.757 of average perturbation, it could reduce the model's accuracy to 0.128, which is there's some work needed to be done on these models. And from here, we could also do some more tests on the bias and deploy models on Kubernetes. So to do the fairness check, we will do the same things. And then you will see KNative also provision a new container for the fairness component. Then we could do the same thing for serving. And for serving, we will define our experiments. So we could group all our training jobs into the same experiment and track them using the KNative revision names. So once you click on deployments, it will also create authentication controllers, which it will create a models with a model with revision names. And we will use that to track our model versions. And usually in the machine learning trainings, we will usually do multiple trainings with multiple parameters and then group them together as an experiment. From here, we want to deploy another models with the different revision numbers, and then we will perform some A/B testing using the KNative route. So now let's create another deployment on the new models. And this model, we will have a revision names model serving 02. And then to apply a KNative route rules is fairly simple. All you need to do is define how many traffic you want to route to a particular revision name. In this case, we're routing 90% of the traffics to model serving 01, and the rest of the 10% traffic to model serving 02. So now let's go ahead and do this. And the route rule is created, and we want to produce some traffic and see how this rule is behave. So now let's go back to our KRE graph and see how our traffic is routing. As you can see, almost 90% of the traffic is routing to the model serving 0.1s, and the rest of the 10% of the traffic is routing to model serving 0.2, which is what we expected. And we could also monitor how the traffic is behaving using the Grafana graph too. And from the app development perspective, it will be seamlessly. So without changing anything on the apps, you could still submit any image. And it works the same way without noticing this A/B testing happening behind the scenes. And now I'm going to give it back to Animesh and talk about how we could orchestrate all this using a pipeline with Argos.
So thanks. What you just saw was that, going through this whole pipeline, step by step. The ideal way to actually do it would be, using KNative eventing, and then, wrapping the whole right-hand side of this into a pipeline, right? So as I said, right, we were definitely evaluating KNative pipelines for this. I think, there is still some work which needs to happen on this side for it to become a robust pipeline platform. There are a lot of bugs and issues, right? For this particular demonstration, we actually created, certain KNative eventive sources, channels, and subscriptions, which can then trigger off beyond the training, how to kick off your pipeline, right? So essentially, once your training is complete, you can actually, send messages to a channel and then have your pipeline subscribe to that particular channel, and the pipeline will then start executing, right? So that's in general, the concept around it. And then, you can actually define KNative pipeline tasks and flow definitions. So KNative actually gives you a very, template-oriented way of defining what are the tasks which you want to run into this pipeline, and then, how to tie them together using the pipeline tasks and the flow definition. For this demonstration, we actually ended up using Argo workflow for pipelining because, as I said, right, we still need to make sure, KNative pipeline becomes a first-class citizen into this space, right? With that, can you bring the browser?
So over here's the
So as you can see, as I mentioned, right, so within IBM right now, we use our own DevOps toolchain pipeline for a lot of these automation, which is built on top of Jenkins. Definitely looking at the world which is more oriented towards machine learning and data scientists. A lot of interesting tools have come up, right? Apache Airflow is a great tool for a lot of pipelining tasks. Argo workflows, which we are right now using for this demonstration when we actually ran that pipeline, is again great. We have Pachyderm, again, a tool which is essentially focused around a lot of the provenance, around data tracking. So something like if you're defining a pipeline using Argo workflow, you can, essentially, you can actually define the whole set of tasks and what you want to do into this pipeline, into the SYAML. So at a concept level, very, very similar what your KNative pipeline defines, right? And to the credit of Argo, this is one of the most mature, workflow orchestrators on top of Kubernetes. It was built for Kubernetes right from the beginning. And then, for individual jobs, once you click on them, you can actually look at their YAMLs, right? A lot of the input parameters, etc., which you want to pass, you can then, get through them. So in that case, what you're seeing is essentially that for a pipelining perspective, right, we have to go outside right now from a Kubernetes perspective. Yeah. So I think some of the lessons which we learned as we went through this whole experiment is, at a concept level, right, KNative brings serverless actions, events, workflows, apps, containers, service mesh in one single stack, right? And definitely most of the modern complex enterprise platforms, they need more than just container orchestration. So KNative is a great fit, right? It eliminates the need for stitching a lot of these components individually, one by one, right? Traffic routing and canary testing on KNative can be done without any Istio knowledge. You get a higher level construct to handle that, right? Built-in monitoring tools are very helpful. KNative eventing shows a lot of promise. I would say, it's in still very early stage where a lot of the definitions around the channels and the subscription needs to be worked out more. And definitely pipeline is something, which needs a lot of work around, creating a robust DevOps operator-oriented pipeline where they can actually go look at the logs, look at the execution times, take certain actions, or from a pipeline you can fire off certain events, right? It gets, so that's an area, which needs a lot of work. So as I said, bringing in all these open source technologies, that's how we are building our open source machine learning platform. Out of this, something like Fiddle, we are actually using internally heavily with KubeBatch in conjunction for distributed deep learning training job. We are using AI Fairness 360 internally for a lot of bias detection in our products. Jupyter Enterprise Gateway is also being used heavily. A lot of the KNative components are in early stages of evaluation, which we are trying out. A lot of the projects and the GitHub links which we talk about are on this particular page, right? So if you do want to go and take a look at some of these projects around, Fabric for Deep Learning, AI Fairness 360, Kiali, which he showed for observing the traffic, all those links are listed here. With that, thanks, and thanks for being here. If you do need to reach out to us, our Twitter handles are listed here with @sign. I'll definitely be open to any more questions and answers now. Did you run into any issues with respect to transferring large models? So large models definitely has been, a lot of our enterprise customers, when they come with models, large model is something, which we see a lot in the enterprises. So we did a lot of work on our Power AI enterprise side for large model support, which we have actually opened up a pull request in both TensorFlow as well as PyTorch. And the idea there is that, the GPU memory is limited in terms of, as your model training is going on, how much weights and the gradients you can keep in GPU. It was 16, now it's 32 gig, but a lot of the models actually need more than that. So for that, we leverage the NVLink at the hardware layer to actually transfer that data, swap it into CPU memory from time to time, and then swap it back, right? So a lot of that work is at the combination of hardware and software layer at that low level. So scheduling, the another question is, how do we use scheduling for resource constraints? So definitely that's where I brought up the project KubeBatch. The idea behind KubeBatch is essentially a scheduling for batch workloads, because most of the AI and ML workloads, they take a long time and they're very compute intensive. So that means, no matter how many GPUs you put behind Kubernetes, when you expose it to your data scientists and ML developers, you will have more demand than what you can provide. So what KubeBatch brings in is the concept of queuing, right? So you can queue certain jobs. The concept of lowering the priority of a certain job because a high priority job has come in. The concept of gang scheduling, right? So for example, if certain jobs need to go, if you launch TensorFlow, you need the TensorFlow parameter server along with the worker nodes all at once or nothing at all, right? So making sure that it can do gang scheduling. The other thing is being resource aware. So the default Kubernetes scheduler is not, right? So KubeBatch is resource aware and it does the placement based on that. Great.
Yes.
Go ahead.
Why do you use Databricks? Do you have any discussions about integration with Databricks? Where does Databricks fit in?
So the question is, why don't we use Databricks? Do we have any discussion with Databricks? So Databricks is a company which is initially behind the Spark ML platform. We contribute heavily to Spark ML. IBM is one of the top 5 contributors of Spark ML. So we do a lot of work with them. In this space, they have a certain project called MLflow, which is exciting to us as we are looking at it. It just happens that we have MLflow, then if you look at the open source landscape, Kubeflow from Google, right? A lot of exciting projects are there. So as part of this, work we are doing in the Code group is essentially, figuring out exactly that right stack around which we need to align, right? Because a lot of our products actually have the same capabilities, the same set of APIs. We have our own open source projects. So we want to make sure, we do it in a way so that we strategically choose the right open source projects, but also make sure they are aligned with the product. But yeah, definitely we do work a lot with Databricks on Spark side. Any other question? Yeah.
In your presentation, you spend a lot of time talking about the KNative, and also you mentioned OpenWhisk. What's the relation between the KNative and the OpenWhisk in your presentation?
So the question was, what's the relationship between KNative and OpenWhisk in our presentation? So essentially, a lot of the eventing, what we were talking about, right? We initially, when we tried it with OpenWhisk, very easy to execute. OpenWhisk has been out there for the last 3 years. It's part of Apache, has heavy contributions from Red Hat, Adobe, so it has matured. So the concept of triggers, actions, and rules, as we call it TAR, you have certain triggers, then you have rules which define based on those triggers what actions to execute. It's very mature. Plus, it can work in a multi-tenant environment. KNative eventing is, I would say, maturing. It's very right now single-tenant oriented. Plus, there is a lot of issues right now on the networking side, essentially to create those KNative channels, being able to have ingress and traffic going outside of those channels, right? So there is still a lot of work which needs to happen. The good thing is, we are actually collaborating with Red Hat and Google and SAP to actually bring OpenWhisk into the KNative eventing mechanism, right? So that means, KNative eventing and KNative serving mechanism. So that means.
That means you use the KNative component eventing, then the trigger OpenWhisk. Is that correct? Because the OpenWhisk, I think you have the package fitting and trigger rules and action, right? So who take the role to?
That's a very interesting question, right? I mean, and that's probably I can talk to you offline. We have our own views around how it should be done, right? And if you talk to quite a few folks in the community, they also think there is a lot which needs to be done on the KNative eventing side. So I can definitely take that, what we are thinking would be the right architecture and how it should be done. And that's a lot of focus for the first half of second year. Yeah. Thanks. Any more questions? Thanks.
Thank you.
I will leave to the